All right, last one. Okay, so with this one, with these two, I'm just going to combine my like terms. Okay, because if this is addition, then I don't really have to worry about the signs. I just go ahead and straight up combine my like terms like this. Negative x squared and negative 2x squared gives me negative 3, or excuse me, negative, you know what I mean? Gives me negative 3x. Negative x and negative 2x gives me negative 3x, and then 1 plus 6 gives me 7. All right, so now this one, part B, is where we might see some issues. All right, I need to think about this second parentheses as having a negative 1 here. And then I need to distribute my negative 1. Okay, so I've seen this done two ways. I've seen it distributed and rewritten. So it's like this, where your teacher just rewrites it. Or I've also seen in the past, okay, some students like to distribute the negative by hand. And what do I mean by that? Making this plus, negative, negative. Okay, whichever one works out for you. I will do it both ways, I suppose. I think this way right here is a little bit more visually appealing to me because I'm just able to worry about combining my like terms. Here I have to worry about changing my signs and making sure I have the correct sign. Here the signs are actually written out for me. All right, so no matter which way you do it, you should get 3x squared minus 4x, okay, then minus 10. All right, the minus 4x comes from the positive 3 and negative 7. The minus 10 comes from negative 5 and the negative 5. That would be our final answer. And it's just simplifying, combining like terms. Are the following expressions equivalent if not provide a counterexample? All right, so what I want to think about here, this goes back to our simplifying this stuff right here. Okay, this goes back to splitting a fraction. So can I split this fraction? Can I split this fraction? Well, luckily here, I can split this as a over 2 plus b over 2. I can't do anything there to simplify it. So now I want to think about, all right, are these equivalent? Let's see if I plug in a and b to be 1. All right, let's say a is 1 and b equals 1. So if I plug that in here, I'll have 1 over 2 plus 1 over 2 to get 1. So 1/2 plus 1/2 gives me 1. All right. Now, here I want to think about it. All right. Let's see here. I would have 2 over 1 plus 1, which would end up being 2 over 2, which would end up being 1. Okay. So now I just found an example where it works. Okay. So I don't think it should work. All right. So what I want to do is, all right, let's try something else out. Let's try, what if I set a and b equal to 4? All right, and why do I do that? Because I know I have to divide a and b by 4 or by 2. So 4 over 2 plus 4 over 2. So that's 2 plus 2, which is 4. All right. If I do this, 2 over 4 plus 4, which is 2 over 8, which is 1/4. These are not equivalent. So there is a counterexample. All right. So these are not equivalent. That's my counterexample there. Okay. I should be able to tell these are not equivalent because there's a binomial on the top and a monomial on the bottom here, and it's the opposite there. It's the reciprocal there. Okay. Are these two equivalent if not provide some sort of counterexample? Well, I know right away that this a plus b quantity squared is really a plus b times a plus b. Okay. And if I do that, that means I have to FOIL here to get a squared plus ab plus ab plus b squared, or a squared plus 2ab plus b squared. That is not equivalent to a squared plus b squared. All right, if I want to provide a counterexample, what do you guys want to use? Okay, yeah, that's a good idea. Let's use a equals 1 and b equals 1. So if I do that, I would get 1 plus 2 plus 1, and then I would get 1 plus 1. Well, these, again, are not equal. All right, 1 plus 2 plus 1 I know is 4. 1 plus 1 is 2. So that's not the same. There's a counterexample. Holy buckets, let me try that one more time. How else could you show a counterexample? By showing this work, all right, by showing this work. Or I could have just plugged this in right away. I wanted to make a point that I wanted you to make sure you remembered that a plus b squared is a plus b times a. All right. Let's conclude our videos. Hopefully those helped.